Hello ladies and gentlemen, welcome to my YouTube channel. Today we are going to wind off Combined Science Paper 2 that was written by November 2025 candidates. But before we move on to the section D, I have an interesting message to all of you. I'm starting my online lessons on 1 November. So I'm enrolling those who want to write in June 2026. I teach mathematics and combined science. And combined science, I teach it from 7 to 8 p.m. Mathematics, 8 to 9 p.m. Lessons are run every day from Monday to Friday. And I charge $10 per month per subject if you want to join the team. So let us now dive straight to number 13. So in the exam, candidates are required to answer N2 questions in the answer booklet provided, but we are going to cover all the questions from number 13 up to number 15 since we are doing our revision. So number 13A part 1, it is reading, state N2 methods that can be used to conserve electricity in the home. The question is having 2 marks, so we need to write on our answer sheet. We are saying on number 13A part 1, the methods of conserving electricity. First of all, we need to turn off the light and appliances when they are not in use. Appliances when not in use. So this is very important because if we turn off lights and appliances when not in use, this is going to avoid the standby power consumption. And also, we need to switch to LED bulbs. We need to switch to LED bulbs. So these are energy efficient and they use significantly less power than the traditional lights. So we need to switch on to LED bulbs. Another way of conserving energy, instead of washing using the warm water, we can wash our clothes using the cold water. So we need to wash clothes with cold water. Instead of hot water. So these are some of the ways of conserving energy at home, right? We can now proceed to next part of the question. So in the next part of the question, we are required to state N2 domestic uses of electricity. So the domestic uses of electricity, this is now part 2. Electricity is used for lighting the homes. We also need the electricity for heating and cooling. We need it for cooking. We need it for water heating. And also, you know that electricity powers various household appliances like the refrigerator, the ovens, microwaves, washing machines, etc. So these are some of the uses of electricity at home, right? And then next we are now on part B. Fig 13.1 shows the generator effect. Explain the generator principle. So we are now on part C of the question. Part B part 1, where we are required to explain the generator principle. So a generator, it is an electrical device that converts mechanical energy into electrical energy. So when we are writing, we can summarize that it is the one that converts mechanical energy into electrical energy. Right, this is how the generator functions. So it is going to convert mechanical energy into electrical energy. So the principle of generator is based on electromagnetic induction, which was discovered by Michael Faraday. So a generator, it has a magnetic field. So when we are explaining, we need to talk about the magnetic field, right? A generator is a magnetic field that is created by the permanent magnet, right? And then as the coil rotates, it cuts through the magnetic field lines, inducing electromotive force in the coil. So we need to talk about the rotation of coil. So this rotation of coil, it is going to induce electromotive force, which is generally known as EMF in the coil. So the EMF, it is the one that causes electric current to flow in the coil, which is then collected and sent to an external circuit. So this is the principle of a generator. Let me summarize again. We are saying a generator is an electrical device that converts mechanical energy into electrical energy. So the principle of generator is based on electromagnetic induction. It has a magnetic field that is created by a permanent magnet. The coil of wire is rotated within magnetic field. So as the coil rotates, it cuts through the magnetic field lines, inducing electromotive force in the coil. So that electromotive force is the one that causes electric current to flow in the coil, which is then collected and sent to an external circuit, right? And then we are now on the part 2. Describe the operation of alternating current generator, 2 marks. So we want now to explain how AC generator works, right? AC generator. So AC generator is driven by either steam turbine or a diesel engine. So it is driven by steam engine either by steam turbine or a diesel engine, right? Either by steam turbine or a diesel engine. These are the two that drives the AC generator. The diesel engine. So the AC generator is driven by steam turbine or diesel engine, which provide the mechanical energy. So that mechanical energy, it causes coil to rotate with magnetic field. So we need to mention about mechanical energy causing coil to rotate. And this rotation, it happens in the magnetic field. So as the coil rotates, there is magnetic flux through it, which is going to change the inducing electromotive force. So the induced EMF produced an alternate current due to periodic reversal of coils, which are positioned within the magnetic field. So we need to mention that the induced EMF. It is the one that produces alternating current. Alternating current due to periodic reversal of coils. So let me summarize again. AC generator is driven by steam turbine or diesel engine, which provide the mechanical energy. Mechanical energy causes a coil to rotate with magnetic field. As the coil rotates, magnetic flux through it, changing the inducing electromotive force. So the induced electromotive force produces an alternating current due to periodic reversal of coils which are positioned within the magnetic field, right? And then state N2 factors that affect the size of voltage produced by a generator. So lastly here, this is now last part of the question. It is part B. So we talk about the magnetic field strength. So increasing the strength of magnetic field results in a higher induced voltage, right? And also we need to talk about the number of turns on the coil. So adding more turns to the coil, it is going to increase the induced voltage. We also talk about the frequency of rotation. The frequency of rotation. So we need to explain this point. The faster the rotation speed, it is also going to result in higher induced voltage. We also need to talk about the speed of rotor. The speed at which the rotor rotates also impact the voltage output with higher speeds, generally producing higher voltage. So that was all about number 13. That was in November 2025. We can now proceed to number 14. Fig 14.1 shows two canes, one painted white and the other one painted black. The canes had equal amount of cold water and were placed at equal distances from the source of heat. So we are now required to suggest the cane in which water heats up faster. So here we are going to write our answer. This is now number 14, right? So on number 14, A part 1, we are going to write black. We are going to write black. So the question is saying, suggest the cane in which water heats up faster. So it is the black cane. And then part 2, explain the answer in A part 1. This is because black is a good absorber of heat. Black is good absorber of heat. And then on part 3, state the cane which cools faster if the source of heat is removed. Again, we are going to write black. the answer on part 3, it is black again. And we are supposed to give the reason. This is because when heat is removed, the black cool faster than the white object, because black are good emitters of radiation. So here on part 4, we write that black is good emitter of radiation. Which allows them to lose heat quickly through the infrared radiation. So on both answers, the correct answer is the black cane, right? And then we need to proceed to B. Fig 14.2 shows a pulley system. We are required to calculate the mechanical advantage of the pulley system. You need to know that mechanical advantage is load over effort. So the load is 360 newtons, the effort is 240 newtons. So when we are calculating on B part 1, this is our B part 1, we are going to say mechanical advantage is equal to load over effort. So the load is equal to 360 newtons, and then we divide by 240 newtons, so that our final answer is going to be 1.5. So this is going to be the mechanical advantage. And then next, we are now required to calculate the efficiency of the pulley system, given that its velocity ratio is 2. So the formula for efficiency, we say mechanical advantage over velocity ratio times 100%. So we are now on B part 2. We are required to calculate the efficiency. So the formula for efficiency, it is mechanical advantage over velocity ratio times 100%. So the mechanical advantage is 1.5, the velocity ratio is 2. So we say 1.5 over 2 times 100%. For us to get our answer is 75%. So this is going to be the efficiency. And next, let us see the next question. State 2 factors that reduces the efficiency of the machine. So we are required to state the factors that reduces the efficiency of the machine. So we talk about the friction. So the friction between the pulley wheels and axle significantly reduce the efficiency. And we also need to talk about the mass of the pulley. A heavier pulley can increase energy required to move the load, thereby decreasing the efficiency. So these are some of the factors that reduces the efficiency of the pulley system: the friction and also the mass of the pulley. If it is heavier, it is going to increase energy required to move the load, thereby decreasing the efficiency. So we are now proceeding to the last part of section D. So the last part is reading. State the function of a carburetor. The carburetor provides correct air to fuel mixture to the engine, ensuring the proper combustion and also the optimal engine performance. So we are saying that the function of carburetor is mainly to provide correct air to fuel mixture to the engine. This is going to ensure proper combustion, ensuring the proper combustion. So this is the function of the carburetor. And then B part 1, outline how the worn out gauge reduces the efficiency of a car engine. Outline how the worn out gauge reduces the efficiency of a car engine. So we are now on part 2. This is going to result in incorrect air to fuel mixture. So the worn out gauge cause air to fuel mixture to become either too rich, that is more fuel, or too lean, that is less fuel, leading to poor engine performance and also decreased fuel efficiency and increased emissions. So we talk about incorrect air to fuel mixture. This is going to result in a fuel to air mixture which become too rich or too lean, leading to poor engine performance, and also increased emissions. Right, let us scroll up for the next question. On part C, we are required to give 3 differences between petrol engine and a diesel engine. And the question is having 3 marks. So we need to create a table for comparison. So we are going to put our petrol engine here. This is the petrol engine. And then this is the diesel engine. And then after that, we can do the comparison. So the first one, this one, it uses petrol as fuel. And then this one, it uses diesel as fuel. This is the first difference. And then the second difference, the petrol engine, it is going to have the spark. It spark the plug. This one, it spark the plug in order to ignite air to fuel mixture. And then this one, it uses what is known as it uses the compression ignition. Right? This one, it uses the spark plugs, and this one, it uses the compression ignition. And then also, another difference between a petrol and a diesel engine. This one, it is difficult to start, especially in cold weather. Difficult to start. We can say difficult to start in cold temperatures. And then this one, it is not affected by cold temperature. by cold temperature. So these are some of the differences between the petrol engine and also the diesel engine. And then on part D, we are required to state advantage of multiple cylinders in an engine. So the advantages of multiple cylinders in an engine. Number one, it is that they provide smoother operation, higher power, and also improved efficiency. By delivering more power pulses. So the advantage is that they provide smoother operation, higher power, and improved efficiency by delivering more power pulses. And then lastly, on part E, let us go to part E. Part E is reading: an electric iron is rated 13 amperes, 250 volts. We are required to calculate the power of the iron, 3 marks. So you need to know the formula that connects power and voltage and current. So we say power, it is equal to voltage times current, right? So the voltage, we are given 250 volts. So we say 250 volts times the current, it is 13 amperes. So we say 250 times 13, we are going to get 3,250 watts. So either we write in watts or we write in kilowatts. To convert from watts to kilowatts, we just need to divide by 1,000. So we are going to get, our answer is 3.25 kilowatts. So this marks the end of the revision of Combined Science Paper 2 that was written by November 2025 candidates. Thank you so much for following me on this channel. Please don't forget to subscribe, like, and share my video.